Hello everyone, welcome to my channel. In this video we are going to discuss about method of separation of variables. This is an important method of solving partial differential equations in physics. So hereafter, instead of pronouncing partial differential equation frequently, we will use the acronym PDE for partial differential equation. And ODE for ordinary differential equation. Equation. Okay. So, what are the steps that are involved in method of in solving the partial differential equation by method of separation of variable? So, in step one, step one, what you have to do? Reduce the given partial differential equation into ordinary differential equations. So the given partial differential equation, okay, involves a function, and that function is a function of two or more variables. Now what we have to do? We have to reduce that PD partial differential equation into ordinary differential equations. The number of ordinary differential equations depend upon the number of variables involved in the partial differential equation. Okay, now this involves multiple substeps, where actually substep 1 that actually involves representation of represent the given function is a product of functions of independent variables. Okay, suppose we have an equation like del square psi by del x square is equal to 1 by c square del square psi by del t square. So here we can see psi, the function psi is a function of x and t. Okay, so how can we represent this x and t variables? Okay, that means in the form of two functions of x and t separately. So where x we will take as a function of x and t we will take as a function of t. Okay, now what we will get in this way? In this way we can represent psi x comma t as x t t. This is what actually written in step 1. We have to represent a given function as a product of functions of independent variables. Then substep number 2, this actually tells that after representing this one, we have to partially differentiate. Okay, partially differentiate the equation twice. Why? Because the partial differential equation may contain second order partial differentiations, may contain first order partial differential equations. So depending upon that, we have to partially differentiate the equation obtained in substep number 1 once or twice, depending upon the requirement. Then 3, substitute the values obtained in step number 2. Step मतलब substep number. Okay, substep number 2 into the given partial differential equation. Okay, now in this substep only you have to separate. Okay, separate the terms containing functions of same variable by rearranging them. So we will rearrange them to separate the terms that contain functions of the same variable. Okay, rearrangements, we can change their side from left side to right side, we can take, or we will divide the whole equation by some term. Okay, to actually separate the terms or eliminate the terms from terms of other functions containing functions of other variables from a particular term. Okay, so this is substep number 3. Then after that, what you have to do in substep number 4, equate them to a constant. Okay, equate them to a constant separately. This constant is called as separation constant. Separation constant, and this can be lambda, k, mu, lambda square, k square, mu square, minus lambda square, minus k square, minus mu square, minus lambda, anything else it can be this constant. Okay, it can be in the form of positive one, it can be in the form of a negative one, it can be in the form of a square. So which constant that you have to take here, that depends upon the requirement and the type of equation involved. So depending upon that, you have to take that, you have to choose the constant. Then substep number 5 is that after choosing the constant, okay, what you have to do, okay, by moving the terms containing the constant to the other side, we equate the whole equation to 0. Okay, equate the equations obtained to 0 by rearranging the terms to obtain the required ordinary differential equations. So this is the last subset of step number 1. So here actually our step 1 ends. Okay, then we will come to step number 2. In step number 2, what we have to do? We have to solve the ODEs that are obtained in step number 1. Step 1. Okay, whatever the ODEs that we have obtained in step number 1, we have to solve them. Now this can be done by two methods. One is by assumed solution method, where a known ordinary differential equation can have a known solution. We will assume a solution, okay, a typical solution for a typical ordinary differential equation, and on the basis of that we will obtain a solution. But in the second one, it is power series solution. Power series solution. So in that case, where the coefficients are not constants and the coefficients are also functions of variables, then in that case we will use power series solution. We will discuss about these assumed solution methods and power series solution methods in the questions in the coming lectures. And for now, you just know that we can solve the ODEs obtained in step number 1 by assumed solution method and power solution methods to obtain the functions of independent variables. Independent variables. So what these functions of independent variables are, that we already discussed in step number 1. Okay, where actually we have represented the given function as a product of two or more functions of independent variables. We will obtain these functions here. Then what to do? Substitute the values obtained into the result obtained in substep 1 of step 1. Okay, so in that substep, what we have obtained? T x t is equal to xx tt. So here the values of xx and tt are obtained in step number 2 by using this assumed solution method and power solution method, and after obtaining these values, again we have to substitute the values of t and x here and find the product. Okay, clear for that? So in this way we will obtain txt, a general solution to txt. Now step number 3. In step number 3, what we have to do? We have to use the boundary conditions. Okay, so apply the boundary conditions to obtain the values of constant coefficients. So this equation that we obtained in this way, okay, that contains constant coefficients. Those constant coefficients value can be obtained by using the boundary conditions. Now after that, what you have to do? Substitute the values in the main equation. The values in the final equation to obtain the particular solution to the given PDE. Okay, so these are the 3 important steps that are involved in solving a partial differential equation. Okay, so like, share and subscribe our channel. Stay tuned to our channel, and don't forget to keep the notification icon on so that you will get notification whenever new lecture videos will be uploaded. Thank you.